Welcome to Metrology lecture series. In the present video, we will discuss the introduction of comparators, need for a comparator, basic principle and classification of comparators, and mechanical comparators. First, we will discuss the what is the comparator. Comparator is a precision instrument used in measurement, and comparators are used to compare the dimension of a component with a standard reference. So comparators are not measure the dimensions. It is the compare the dimension of a component with a standard reference. In general, standard reference as the slip gauges or the gauge blocks. So comparators does not measure the actual size directly. Instead of this, it shows the difference between the component size and the standard size. The difference measured is usually very small. Therefore, a magnification system is used to enlarge the small difference and make it easy to read and interpret. So therefore, a comparator is a precision device used for indirect measurement by comparison with a standard which works on relative measurements and it gives the dimensional difference with respect to the basic dimensions. So comparators not giving the exact dimensions of a component, it will shows the difference between the dimensions of the component and the basic dimension. And comparators may be used for direct measurement within its range of operation. Moreover, this has a sensing device, magnifying or amplifying system and a display system to provide suitable readout. So comparators having the three systems. One is the sensing device system, magnification or amplifying system and the display system. And comparators are provides high speed accuracy and precision for inspection in mass production. Comparators are especially used in the mass production and comparators are used for linear measurements. Next we will discuss the need for a comparator. In mass production, a large number of identical parts are made. For a proper interchangeability, all parts must be within closed dimensional tolerances. So in the mass production, producing the similar parts with a large number of size. In this regard, all the parts must be interchangeability, which means all the parts must be within the closed dimensional tolerances. So inspection is mainly about the checking how much the part is difference from the standard size. In this regard, if we are measuring with the dimensions of the components with the vernier caliper or the micrometer, it requires skilled operators and take the more time for measurements. Moreover, it is not suitable for large scale production. So in this regard, while using a comparator having the advantages, that is the requires little or no skill operators. Moreover, these comparators are the fast measurements which saves the time and reduce the human errors. So while like the parallax error, these kind of the errors we should be eliminated with the help of the comparators. And also comparators gives consistent and reliable results. Next we will discuss the basic principle of operation of the comparators. First we have to set the comparator to a reference value h1. So we have to observe the in the schematically. So first we have to take the standard one. Let's consider the height of the standard specimen is the h1. At the height of the h1, plunger is touch with the standard specimen, and in the respect to the height we have to set the reading value is the 0. Next we have to replace the standard with workpiece and measured H2. Let consider height of the workpiece is H2. Then we have to replace the standard with the workpiece. Now we have to observe the difference of the pointer. If there is any differences in the height difference, standard height and the workpiece height, these difference it will be shows in the readings. So the difference H1 minus H2 will be display on the dial. Moreover, this difference is magnified into the 1000 to 3000 times. So this is the basic principle of the operation of comparators. Next we will discuss the uses of comparator. The various ways in which comparators can be used are, first one is the laboratory standards. Comparators are used as laboratory standards from which working or inspection gauges are set and correlated. And second uses are the working gauges. Comparators are also used as working gauges to prevent spoilage and to maintain required tolerance at all important stages of manufacture. So next, third use is the final inspection gauges. Comparators may be used as final inspection gauges where selective assembly of production parts is necessary. And fourth application is the receiving inspection gauges. As receiving inspection gauges, comparators are used for checking parts received from outside sources. And last use is the for checking newly purchased gauges. The use of comparators enable the checking of the parts in mass production at very fast rate. So these are all the uses of comparators. Next we will discuss the essential characteristics of good comparator. First one is robust in design and construction. The design and construction of the comparator should be robust so that it can be withstand the effect of ordinary uses of comparator, and it should not affecting its measuring accuracy. And second one is the compact and easy to handle. And third one is the linear characteristics of scale. Recording or measuring scale should be linear and uniform, and its indication should be clear. And next one is the high magnification. The magnification of the comparator should be such that the smallest division in a size of component can be easily detected. And next one is quick in results. The indicating system should be such that the readings are obtained in least possible time. And next one is the versatility. Instrument should be designed that it can be used for wide range of measurements. And next one is the minimum wear of contact point. The measuring plunger, which is the contacting with the workpiece and the standard. So the measuring plunger should have hardened steel, contact or diamond to minimize the wear effect. Moreover, contact pressure should be low and uniform. And next one is the free from oscillations. The pointer should come rapidly to rest and should be free from the oscillation. So it should be come rapidly to rest and free from the oscillations. And next one is the free from the backlash. System should be free from backlash and unnecessary friction, and it should have the minimum inertia. And next one is the quick inspection of workpiece, which means should be provided for lifting the plunger for quick inspection of the work. And next one is the compensation from temperature effect. The indicator should be provided with maximum compensation for temperature effects. Next, we will discuss the components of comparators. All comparator consist of three basic components. First one is the sensing device. Second one is the magnifying or amplifying system. Third one is the display system. First we will discuss the sensing device. Sensing device means which senses the input signal faithfully. Let's consider in the dial gauge, plunger is the sensing device which is the identifying the height difference between the standard and the component. And next one is the magnifying or amplifying system. So magnifying or amplifying system increases the signal to suitable magnitude. In general, the difference between the slip gauges and the component height is very small, which is we can't able to identify with the naked eye. In this regard, this difference should be magnifying by the different mechanical or electrical components. So in this regard, magnifying or amplifying system, mechanical, optical, pneumatic, hydraulic and electronic methods are used for this purpose. Next one is the display system. So for the dial gauge example, have to see pointer and the dial gauge is the display system, which has to be display the differences between the component and the standard. So the display system utilize the amplified signal to provide a suitable readout. So next we have to discuss about the classification of comparators. A wide variety of comparators are commercially available at present. They are classified according to the method used for amplifying and recording the variations measured in the following types. First one is the mechanical comparators. Second one is the optical comparators. Third one is the mechanical optical comparators. Fourth one is the electrical and electronics comparators. Fifth one is the pneumatic comparators. Sixth one is the fluid displacement comparators. Seventh one is the projection comparators. Eighth one is the multi-check comparators. Next, ninth one is the automatic gauging machines. And last one is the electromechanical comparators. So now we will be discuss the one by one type of the comparators. First we will discuss about the mechanical comparators. So in the mechanical comparators, principle of working is the mechanical comparator uses mechanical parts to magnify very small movements. When the measuring stylus touches the part, any small difference between the standard size and actual size causes a small movement. So this small movement we can be magnifying by using the mechanical components. In this regard, this we are calling as the mechanical comparator. So yes, this small movement is magnified using mechanical systems such as the levers, gear trains, rack and pinion or a combination of these. The range of magnification of the mechanical comparators are the, in general, 250 to 1000 times. There are the different types of mechanical comparators are there. First one is the dial indicator. Second one is the sigma comparators. Third one is the Johansson Mikrokator. Fourth one is the reed type comparators. So let's have to discuss one by one. First we will discuss the dial indicator. So this is the schematic representation of the dial indicator, which is using in general in the industries. So dial indicator is the simplest type of mechanical comparator. It is consist of base with a rigid column rising from its rear. An arm is mounted on this column and carries the dial gauge. The arm can be adjusted vertically up and down movements along with the column. Moreover, an anvil or work table is fixed on the base and act as a reference surface. And moreover, the workpiece is placed on this surface during the measurement. So this is the simple comparator is suitable for checking components with a tolerance of about plus or minus 0.05 mm. Next we will discuss the principle of operation of the dial indicator. In the dial indicator, a suitable spring gives constant plunger pressure. So in the schematic you have to observe here, this plunger is always contact with the reference or the workpiece, and moreover at the end of this plunger is contacting with the suitable spring which gives the constant plunger pressure. A very slight upward pressure on the spindle at the contact plunger is magnified through a system of gears and levers and is indicated on dial by pointer and scale. So initially plunger is contact with the standard. In this condition we have to set the reading is the 0. Then we have to replace the standard with the workpiece. If there is any variations, height of the workpiece with respect to the standard, then this plunger will give the vertical movements. These vertical movements are the very small, especially in the microns. So these microns we can be magnified with the help of this rack and pinion system. And moreover, this difference is displaying in the dial and pointer scale. So this is the principle of operation of the dial indicator. The linear movement of the plunger is magnified by means of a gear and pinion train into sizable rotation of the pointer. The variation in dimension of the part from the basic size is indicated on the dial. So let's see the main parts of the dial indicator. First one is the plunger. So this is the plunger. So in general, plunger is moves up and down when it touches the workpiece. Next one is the rack. So here I have to observe. So plunger always connecting to the rack. So linear teeth on the plunger which has the convert the linear motion into the rotary motion of the pinions. Next one is the pinion gear. Pinion gears are used for the engages with the rack, and this is convert the linear motion into the rotary motion. Next one is the gate train. The size of the gate train amplifies the small movement for better readability. Next one is the pointer. So this is the pointer. So pointer or the needle shows the displacement of the dial. Next one is the dial scale. So dial scale is the graduated circular scale. And next one is the spring. So observe, this is the spring. So which has to ensure the plunger returns to its original position. Next one is the casing. So body. So which has the protects the internal mechanism. So these are the main parts of the dial indicator. Next we have to discuss about the working principle of the dial indicator. First, plunger touches the surface. In this regard, moves the linearly. Then rack is attached to plunger moves. So here these plunger movements are attached to this rack. Then this rack is rotate the pinion. Then gate train amplifies this rotation. Then this rotation pointer has to be moves on the dial which has to shows the deviations. Let's see the applications of the dial indicator. So first application is the comparing two heights or distance between the narrow limits. And next application is to determine the errors in geometrical form such as ovality, roundness and the taper. Next application is for accurate measurement of deformation. Next one is to determine positional errors of surfaces such as the parallelism, squareness and the alignment. So next we will discuss about the next comparator. Next we will discuss about the Johansson Mikrokator. So this is developed by the C.F. Johansson and this is the schematic representation of the Johansson Mikrokator. So here observe, so first one is the plunger. In general, this plunger is contacting with the workpiece and this is connected to the bell crank lever and this bell crank lever is connected to the twisted strip and in the center of the twisted strip there is a line pointer and moreover at the end of this twisted strip there is the cantilever strip. The main mechanism of in this instrument is, so there is the linear movements will be occur in the plunger because of the variations of the workpiece and the standard one. In this regard, this linear motions is so rotate by the bell crank lever and this rotation causes for the twisting in the twisted strip. Due to this twisting, light pointer has to be rotate in the big circular one. So basic principle is the linear motion of the plunger is converted to the big circular arc of the pointed strip. So let's see the discussion. So measuring plunger which is passes through the slit washer. So this is the slit washer. So this is the measuring plunger and this measuring plunger transmits its motion through the bell crank lever to the twisted metal strip. A thin metal strip is twisted and its center it holds a very light pointer which is made of the thin glass. Moreover, it uses a twisted strip to turn a small straight movement of the plunger into big circular movement of the pointer. So moreover, I have to observe this twisted strip is one end of the strip is fixed to a adjustable cantilever strip and another end is connected to the spring elbow. Moreover, one arm of the spring elbow is attached to the measuring plunger. So this is the basic construction of the Johansson Mikrokator. And moreover, this spring elbow act as a bell crank lever. A slight upward movement of the plunger will make the bell crank lever to rotate. So here first we are converting this linear motion of the plunger into the rotary motion of the bell crank lever. Then because of this, tension is applied to the twisted strip in the direction of the arrow. This makes the strip untwist which moves the pointer. So then this rotary motion causes for the twisting of the twisted strip. Due to this one, this pointer it will be rotate into the big circle. The spring makes sure the plunger goes back to its original position when there is no contact with the workpiece, that is when the workpiece is removed from the below the plunger. So when we are removing the workpiece below the plunger, it come to the initial position. The length of the cantilever can be changed to adjust the magnification to avoid too much stress in the middle. Thus, in general, the strip is made with small holes along its center. Next, we have to discuss about the magnification of the instrument. Magnification of the instrument is approximately equal to the ratio of rate of change of pointer movements to rate of change in length of the strip, which is the dq by dl. Here q equal to the twist of midpoint of strip with respect to the end, and L is the length of the twisted strip measured along its neutral axis. So the magnification of instrument, we can be stated that dq by dl is directly proportional to the L by W square N. So here where the L equal to the length of twisted strip and W is the width of the twisted strip and N is the number of turns. So next we have to see the another type of the comparator is reed type comparator. In reed type mechanical comparator, the measuring unit is usually a sensitive and high quality dial indicator, and the dial indicator is mounted on a base and supported by a strong vertical column. So next we have to discuss the main parts. So this is the schematic representation of the reed type of comparator. So this device has the two blocks. One is the fixed block A. So this is the fixed block. So this is the fixed block. Another one is the floating block. So here B is the floating block. So it will be float. And next one is these two blocks are connected by horizontal reed. So here observe in the schematically. So here fixed block as well as floating block. So these both are connected by these horizontal reeds. So this is we are calling as the reeds. So in this here it is in the horizontal position. So these two blocks, fixed block as well as the floating block, both are connected by the horizontal reeds, and moreover there is the vertical reeds also there. So this is the vertical reeds. So here these are the vertical reeds. These are attached to both blocks and their top ends are joined together. So at the top ends these two are at the joint, and moreover the pointer which is fixed at the top joint to indicate the movement on a scale. On the top joint it will be connected to the pointer. So next we have to discuss about the working principle. When the spindle moves due to the measurement, the floating blocks moves vertically, and these vertical movements causes the vertical reed of the floating block to move relative to the fixed block. So this floating block it will be moved. Since the top ends of the vertical reeds are joined, so they cannot slide freely. Instead, both the reeds bend and swing an arc. So due to this vertical movements of the floating block, there should be the swing it will be occur. So in this regard, the swinging motion moves the pointer, which has to be giving a magnified reading on the scale. So let's see the advantages. Reed mechanism is frictionless, so it gives high accuracy. Scale is calibrated using gauge blocks to measure deviation from a standard size, and the mechanical magnification is usually less than the 100. So while this is connecting with the optical system, then total magnification can be increased to 500 to 1000 times. So this is about the reed type comparator. Next we will discuss the sigma comparator. This is a mechanical comparator which gives high magnification. In general, the magnification is 300 to 5000 times. So let's see the construction of the sigma comparator. So this is the schematic representation of the sigma comparator. Here observe the plunger is attached to a bar. So this is the bar and this is the plunger. So this plunger is attached to a bar which is the supported between the bending plates at the top and bottom. So here observe. So plunger is attached to the bar, and moreover this bar is supported between the bending plates. One is at the bottom side, another one is at the top side. the bar can move in the vertical direction only. Moreover, a knife edge is fixed to the bar. So here observe, the bar is fixed to the knife edge. The movement of the knife edge exerts the force on the moving block through the sapphire plate. So here observe the principle of this one is, so plunger is connected to the bar and this bar is fixed to the knife edge. So when the plunger is having the linear motions up and down, similarly this bar also move to the up and down motion. Now, so this knife edge also having the same up and down motion. So when it is moving up and down motions, it will be cause the force on the moving block. So here observe, it is having the, so one sapphire plate is there. This plate is consisting of the fixed block as well as the moving block. Now, a small force is exerted on this moving block through this sapphire plate. Moving block is attached to the fixed block with the help of the crossed strips. So here observe, this is the movable block. Here force is exerted by the knife edge, and this fixed block as well as the moving block are the connected with the help of the crossed strips. So let's see the working of the sigma comparator. So in the schematic you have to observe here. So this sapphire plate is connected to the Y arm and Y arm is connected to the driving drum as well as the pointer. Now force is exerted through the knife edge on the moving block. Then this moving block is attached to the Y arm. Then these angular deflections causes for the movement of the Y arm. Then this movement of the Y arm, then pointer also it will be rotate. A Y arm transmit the rotary motion to the driving drum of the radius R. This deflects the pointer and reading is noted. So let's see the magnification of the sigma comparator. The magnification is depend on the capital L length of the Y arm, and also it is depend upon the X, that is the distance from the hinge pivot to the knife edge, and also this magnification is depend upon the capital D, that is the length of the pointer, and capital R, so radius of the drum radius. So magnification equal to the L by X into D by R. So magnification having the linear relation with the length of the arm and length of the pointer, and it is having the inverse relationship with the knife edge distance and the driving drum radius. So let's see the advantage and disadvantage of the sigma comparator. First one is the safety. So because of the knife edge follows the movement of the hinge member. So if a sudden shock or excessive movement occur in the plunger, it cannot be transferred to the mechanism, which has to protect the instrument from the damage. Second one is the deadbeat readings. A non-ferrous disc is attached to the pointer spindle and moves within the field of permanent magnet. So this arrangement provides the quick and safety readings without oscillations. Next one is the parallax error. Parallax error is reduced by providing a reflective strip on the scale, which has to help the user take the accurate readings. And next one is the contact pressure. The magnetic plunger is used to maintain the uniform measuring pressure throughout the instrument's range. Next one is the fine adjustments. Instruments allows the precise and fine adjustments, which has to improve the measurement accuracy. So let's see the disadvantages. So due to the motion of the parts, there is a wear in the moving parts. And another limitation is it is not sensible as optical comparator due to friction of the moving parts. So this is the discussion of the mechanical comparators, and thank you.